Let your thoughts drift. Out beyond the noise of cities, past the whispering trees, further than the clouds that cradle the moon. Far above your own heartbeat, the universe breathes. Its rhythms are ancient. Its truths stranger than fiction. And yet, somehow, they always wait patiently for us to notice. So close your eyes now, and let wonder guide you gently. We'll begin not with stars or galaxies, but with something even more invisible. 1. The universe is mostly nothing. You are floating in silence. But it is not silence. It is space, and space is not empty. Not really. Everywhere you look, it seems like there's nothing there. But that nothing has structure. It has weight. It has tension. Even the void hums with invisible fields, stray photons, and the quantum foam of uncertainty bubbling just beneath perception. Take your hand, for instance. Hold it out. The atoms in your hand are mostly empty space, tiny nuclei surrounded by electrons dancing at vast distances, proportionally speaking. If you removed all the empty space from the atoms that make up your body, you'd fit into something smaller than a grain of rice. And if you did that for everyone on Earth, we'd all fit inside a sugar cube. Matter is sparse. Emptiness is the rule. But the emptiness is not meaningless. It's where energy moves, where gravity whispers, where time stretches. In this nothing, everything happens. And the deeper you look into that stillness, the more alive it becomes. 2. Even nothing has a temperature. So now you're floating in what you thought was emptiness. But reach out, not to touch, but to feel. The void is not cold in the way your fingers know. It is cold in the way time forgets. Because even where there is no sun, no stars, no planets, there is still temperature. Still the echo of something older. It's called the cosmic microwave background. A soft afterglow. A faint, invisible light stretched thin by the expansion of space. It fills every corner of the universe like the dying breath of a long-forgotten fire. It is only 2.7 degrees above absolute zero. That's minus 270.45 degrees Celsius. And yet, it is not dead. It is the memory of the Big Bang. The residue of light born 13.8 billion years ago, still wandering, still humming, still warming the cold with the faintest ghost of heat. So even when you are surrounded by nothing, the nothing is glowing. Not with fire, but with memory. And as your body drifts deeper into this dark, quiet field, the warmth of ancient light brushes past you, like the breath of time itself, whispering that it was here, long before you, and will still be here, long after. 3. Galaxies drift like slow-motion whispers. In the silence of space, speed becomes a kind of illusion. Because everything is moving. Not with chaos, but with elegance. Galaxies are drifting apart, not crashing, not tumbling, but floating. Like petals on a black ocean, slow enough to seem still, fast enough to outrun sound, thought, even the meaning of speed itself. The Milky Way, your galactic home, is soaring through the cosmos at about 1.3 million miles per hour. And yet, you don't feel a thing. Because space doesn't resist. It doesn't hold you back. There's no wind to feel. No friction to sense. Just motion. Every galaxy is fleeing from every other, not because they're afraid, but because the fabric of the universe itself is stretching. Not like rubber, but like breath. And the farther they drift, the faster they seem to flee. It's called cosmic expansion. But that phrase doesn't capture the stillness of it. The deep, ancient patience. If you could watch it from outside time, you'd see galaxies blooming and fading like slow sparks in an infinite dark. A ballet of light, choreographed by silence. And so you drift too, quietly, gently, like the galaxies, never still, but never hurried. Just floating in the widening breath of the cosmos. 4. The dark that binds us. Not everything in the universe shines. Some things pull. Some things hold. Between the glowing galaxies and the blazing stars, something invisible is at work. Something that doesn't emit light, doesn't reflect it, doesn't interact with it at all. And yet, it shapes everything. Dark matter. You've never seen it. No one has. But without it, the galaxies would unravel. Stars would drift like lost boats, and gravity would be a whisper instead of a law. It doesn't clump like regular matter. It doesn't glow or burn. But it's there, in the halo of every galaxy, in the filaments that stretch across the universe like spider silk drawn tight. Scientists call it dark not because it's evil, but because it hides. It hides in the math. In the way galaxies spin too fast at their edges. In the strange patterns of cosmic microwave background. In the shadows cast by gravity's lens, bending light from behind invisible masses. And you, floating here, are wrapped in it too. Your body is passing through rivers of dark matter every second. It brushes past you silently, untouchable, untamed. The stars may light the sky, but the darkness holds the frame. 5. Threads of the cosmic web. If you could step back far enough, so far that galaxies shrink into pinpricks, you'd begin to see it. The structure beneath the stars. The universe is not scattered like confetti. It is stitched. Galaxies do not float randomly through space. They cluster. They stretch. They form filaments, vast bridges of matter, connecting distant clusters like veins of light across an infinite canvas. Between these threads lie cosmic voids, dark, silent stretches of nothingness. Places where gravity gave up, where matter never bothered to gather. But the filaments, they hum. They stretch for hundreds of millions of light years, each a highway of galaxies drawn together by the quiet magnetism of gravity. And in this spiderweb of space, our own Milky Way is but a bead of dew caught in the lace. Astronomers map it with radio waves and redshifts, tracing the invisible highways that bind galaxies across unfathomable distances. From the Laniakea supercluster to the Sloan Great Wall, every glowing point we see is connected to something else, threaded together by ancient forces. The web pulses with history. It remembers the Big Bang. It whispers the architecture of everything. And as your breath slows and your thoughts drift, the cosmos stretches out its scaffolding, quietly, patiently, knitting time, space, and dust into a single woven whole. 6. The light that left before we were born. Every star you see in the night sky is a memory. Because nothing in the cosmos arrives on time. That twinkle overhead. It began its journey before you did. Some stars sent their light when humans were drawing on cave walls. Others, when there were no humans at all. And a few, perhaps, are already gone, extinguished in silence while their last beams still drift through the dark, racing toward your eyes. The universe doesn't offer live broadcasts. It offers relics. Telescopes are time machines. Every photon is a message delayed. When astronomers peer into the deep field, they don't see what's out there now. They see what was. Billions of years ago. Galaxies forming. Stars dying. The fog lifting after the Big Bang. Look up and you see a million ghosts. Some galaxies we've captured on film are so far that their light began traveling when Earth was a hot, molten sphere with no oceans, no sky. Just fire. And yet, here you are, on a calm night, catching their final flicker. No sound. Just a quiet ripple of history landing softly on your retina. The present doesn't truly exist. Not out there. The deeper you look into space, the further back you drift. Into before. Into what was. And slowly, as the world outside your window sleeps, the sky above keeps whispering. This is all memory, all light delayed. And you are always watching the past. 7. The sound that never came. Space is not silent because there is no sound. It is silent because sound cannot live there. In the void between stars, there is no air to carry a whisper, no molecules to vibrate, no echo, no scream. The explosions of supernova, the collapse of stars, the rush of comet tails, all unfold in perfect silence. And yet, Earth is loud. Because here, sound has something to hold onto. It rises on air, dances through water, trembles across skin. A baby's cry, a wolf's howl, a whale's song. All impossible just beyond the atmosphere. Astronauts say space is eerily still. You look out the window and see chaos, storms on Jupiter, solar flares erupting. But your ears hear nothing. Just your own breath, the hum of machines, the blood in your head. Imagine the sun roaring with heat, and yet, not a single sound escaping. Even the giant collisions, black holes devouring stars, galaxies merging, dark matter crashing through the Milky Way, are silent. But science has found a trick. We've taught computers to turn gravitational waves into sound, to let us hear the moment two black holes collided a billion years ago. It comes as a low, rising chirp, a tiny hiccup in space-time. It's not music. It's the memory of a ripple. The universe has no voice, but sometimes, if we listen carefully, we can still hear its heartbeat. Not in noise, but in the quiet curves of space-time bending like a breath. 8. The shadow that shaped everything. Light may be our guide, but shadow is its companion. For every galaxy that spins in radiance, there is a web of darkness holding it in place. Invisible. Immense. Unseen by any telescope. Yet without it, everything would drift apart. We call it dark matter. Not because it's sinister, but because it hides. It does not shine. It does not burn. It does not touch us, not the way sunlight touches skin. But it's there, wrapping galaxies in halos, holding clusters of stars together like cosmic glue. Quiet scaffolding for the universe. We found it by watching things move. Stars at the edges of galaxies spinning too fast, like dancers refusing to slow down. They should be flung into the void, but they stay. Something is holding them, something we cannot see. So we mapped the invisible. We watched gravity pull where nothing seemed to exist, and the outline appeared. A ghost of the universe. 27% of all that exists is made of this dark matter. Not atoms. Not you, not me, not stars. Something else. Something older, quieter. It drifts through us every second. Trillions of particles flowing through your body like a breeze you'll never feel. Physicists built detectors deep underground. Giant tanks of xenon, wrapped in silence, waiting for a single touch. So far, the dark has not spoken. But we know it's there. Holding galaxies like threads, catching starlight in its arms. And somewhere out there, in the quiet between things, it waits. Not to be found, but to be understood. 9. The expanding silence. The stars are not standing still. Every second, the fabric beneath your feet is stretching, carrying entire galaxies farther and farther from one another like ink on an inflating balloon. The universe is not just big, it's getting bigger. Not slowly, but faster. And not like a balloon that's puffed up and stops, but one that accelerates as if some unseen force is pushing space apart. A gentle, constant pressure that doesn't roar, but whispers. Expanding silence. We call it dark energy. Not because we understand it, but because we don't. It accounts for nearly 70% of the entire universe. And yet, we only know it exists because of what it does, because of how galaxies recede. Not falling away from each other, but carried on the tide of stretching space. It's not motion, it's expansion. Galaxies aren't flying through space. Space itself is growing between them. A cosmic breath inhaling without end. Imagine two dots on a rubber sheet. As you stretch the sheet, the dots move apart, not because they're moving, but because the fabric beneath them is growing. That's us. That's everything. In the early days, gravity tried to slow it down, pulled things inward, but dark energy won. And now, the universe is not just drifting into distance, it's accelerating into it. Eventually, even the closest galaxies will disappear from view, their light too stretched to reach us, like lanterns slowly fading into a fog of nothing. Not with a bang, but a gentle vanishing. And the question hangs, unanswered. What is this dark energy? A property of space itself, a new force, a flaw in our understanding? We don't know. But the expansion continues, quiet, relentless, unstoppable. And in that silence, everything drifts. 10. The coldest place that exists. As space expands, it stretches not just light, but temperature. The further it grows, the colder it becomes. And somewhere out there, far beyond our reach, beyond stars and filaments and galaxies, lies the coldest desert imaginable. Not ice, not wind, just the absence of everything. The Boomerang Nebula, drifting 5,000 light-years away, holds the current record. 1 degree Kelvin. Colder than the cosmic background itself. Colder than outer space. But it's not the only cold. The universe is littered with pockets where heat has flowed. Black voids where matter never formed. Cosmic shadows between galactic clusters. Silence so perfect it has a temperature. Out there, cold becomes a sculptor. It slows atoms to stillness. It silences movement. And in places we'll never stand, never breathe, never see, it rains. But the most haunting cold of all isn't in some distant nebula. It's coming for everything. Because expansion brings isolation. Isolation brings stillness. And stillness is just a heartbeat from freeze. Eventually, galaxies burn out. Stars blink off. No new light is born. And the universe, once blazing, pulsing, alive, falls into a quiet coma of black dwarfs, cold dust, and drifting particles. We call it heat death, but it's more like cosmic hibernation. A final breath exhaled into infinite nothing. No fire, no fury, just space so cold it forgets it ever held stars. And yet, even in the coldest corners, particles still twitch. Quantum uncertainty refuses to let the universe go completely still. A rebellion in the freeze. And somewhere, a single photon still travels, endlessly. 11. The photon that never stops. Imagine being born from the heart of a star. Not with limbs or lungs, but as a photon. A sliver of light. No mass, no rest, just pure momentum. The universe gives you no choice but to move forever. Photons don't age like you do. They don't slow down. From their perspective, they experience no time at all. The moment they're emitted is the moment they arrive, no matter how far they travel. They leave stars, bounce from atoms, reflect off moons. Some escape galaxies altogether. And once they do, they rarely stop. They travel for billions of years, across cosmic webs, through voids where galaxies used to be, beyond clusters dissolving into darkness. You might be catching one now. From a star that died before the dinosaurs walked. From a supernova that bloomed and withered before your language had words for light. Every glimmer you see in the night sky is a ghost. A message written eons ago, arriving just now. And still, millions more pass by your skin, invisible, unnoticed. Sliding through your bones at the speed of causality. Even now, the background hum of the universe sends its ancient photons. Remnants from the Big Bang, drifting through your body. They are the oldest travelers. Never resting. Never tired. And when the last stars die, when space stretches so far that light can no longer bridge the gaps between galaxies, those photons will still go on, alone. Not because they have somewhere to be, but because stopping was never in their nature. 12. The universe is transparent, But it wasn't always. Close your eyes and imagine standing in a room filled with fog so dense, even light gives up. That was our universe, once. In its earliest moments, after the Big Bang, everything was hot. So hot that atoms couldn't exist. Just a sea of particles, protons, electrons, photons, all colliding, scattering, bouncing like an endless, glowing soup. Light tried to move, but couldn't go far. It was like shouting in a thunderstorm. Every voice drowned in static. The universe was bright, but blind. There were no stars yet. No galaxies. Just a radiant fog where light couldn't travel freely. Then, cooling. The universe expanded. Temperature dropped. And suddenly, about 380,000 years after it all began, something miraculous happened. Atoms formed. And the fog lifted. This moment, called recombination, was the first time light was free. It stretched its limbs and soared. That ancient light still travels today. We call it the cosmic microwave background, a baby picture of the cosmos still echoing through space. And here's the beautiful part. It's everywhere. Right now, that primordial light is slipping through your room, brushing past your eyelashes, curling gently in the silence between your thoughts. The universe became transparent. And in that transparency, time began to mean something. Direction mattered. Shadows could exist. And all of it, every galaxy, every star, every story, happened after the fog cleared. But that fog, it never really left. It's there, between moments, waiting. 13. There's no true up or down in space. We like to think we're grounded. That up is the sky and down is where your feet land. That space has a top and a bottom. But float away from Earth, and those directions dissolve like mist in sunlight. In the universe, there is no top, no ceiling, no floor, just motion. If you were to drift outside your planet, beyond the satellites and the rings of invisible orbiting debris, you would no longer feel a pull. You'd float, not because you are weightless, but because the space around you has no agreed-upon direction to define what weight even means. In space, everything moves relative to everything else. Galaxies swirl in elegant pirouettes. Moons loop around their planets, which dance around stars, which spiral around galactic cores. There is no stationary frame. No preferred side of the cosmic dice. Astronauts train for this disorientation. Flip a camera upside down in orbit, and you can't tell the difference. Up becomes whichever way your head is pointing. Down is just a feeling you remember. Even Earth isn't upright. It's tilted at 23.5 degrees. A cosmic lean that gives us seasons, sunlight, and the gentle slosh of time. But it's only tilted because we say so. Compared to what? The universe doesn't mind our orientation. It just is. No compass, no floor, just drift, just spin, just endless motion in every direction, and none at all. 14. Neutrinos. The ghost particles passing through you. Right now, this second, billions of particles are passing through your body. They don't knock. They don't stop. They don't even slow down. They're called neutrinos, and they're some of the most elusive matter in the universe. Born in the hearts of stars and in the violent aftermaths of nuclear reactions, neutrinos are almost weightless, almost invisible, and almost unstoppable. They move at nearly the speed of light and barely interact with anything. Not your bones, not your blood, not the Earth itself. Every second, trillions pass through your fingernail, through the mountains, through the core of the planet, like whispers that ignore walls. And yet, they're real. To detect them, we build vast underground chambers. Entire lakes of ultra-pure water buried beneath rock, shielded from all other noise. Occasionally, so very occasionally, a neutrino will brush against an atom just enough to light up the water with a flash. A blink. a momentary signature of something that usually leaves no trace. They come from the sun, from exploding stars, from radioactive decay, from the Big Bang itself. And here you are, being gently threaded by the fabric of the cosmos without ever knowing. You're never alone in the void. The silence is full of motion. Invisible rivers run through you, all the time, without asking permission. The universe moves through you, not just around. And the neutrinos carry on. 15. The coldest place in the universe isn't in space. You'd think the coldest place in the universe would be somewhere far away, out in the distant black between galaxies, where starlight doesn't reach and time forgets to tick. But no. It's here, on Earth, inside a lab. Deep beneath the surface, scientists have built traps for atoms, slowing them with lasers until they barely move at all. Temperature, after all, is just motion. So when an atom is nearly still, it's nearly absolute zero. Minus 273.15 degrees Celsius. The floor of thermodynamic possibility. They've come closer to that edge in a basement laboratory than anywhere else in the universe. Not in a black hole. Not in intergalactic space. Right here, where someone eats lunch upstairs. Why? To watch matter do strange things. To see atoms overlap. To coax them into states that don't exist in normal life. Superfluids. Bose-Einstein condensates. Quantum illusions frozen into reality. At these temperatures, things stop behaving like things. A cloud of atoms might act like one single atom. An object might flow up the walls of its container. Particles become smeared, unsure of where they are. We're used to science making things hot, engines, explosions, stars. But some truths only emerge when everything is still. When all heat is gone. When there's nothing left to burn. In the deepest cold, matter dreams. And in those dreams, the laws of physics begin to whisper secrets we can't hear anywhere else. 16. Saturn's rings are younger than the dinosaurs. They seem eternal. Those soft, shining bands encircling Saturn, so delicate, so ancient looking. Like the fingerprints of a god who once shaped planets by hand. But they're young. Not young like a child. Young like a recent echo. No more than 100 million years old. Maybe less, which means when the dinosaurs walked the Earth, Saturn was bare. No rings, no icy halo. And if you'd looked up from a telescope back then, you'd have seen a planet without its crown. Scientists know this not because they guessed, but because of dust. Tiny bits of cosmic soot constantly fall from space. And the rings? They're too clean, too fresh. Not enough dust has gathered on them for them to be old. So, something happened. Something big. Maybe a moon shattered, torn apart by Saturn's gravity. Maybe two icy bodies collided and the fragments spread. Whatever it was, it happened recently by cosmic standards. And here's the stranger part. They're disappearing. Every second, Saturn's gravity pulls ring particles inward. Like rain. Ring rain, scientists call it. A slow, glittering death. In another 100 million years, the rings might vanish entirely. Just a brief ornament in the long life of a planet. We may be living in the only era when Saturn wears jewelry. The only time in history, past or future, when a species with eyes and wonder and telescopes can look up and see them. A fleeting crown on a world that was once bald and soon will be again. 17. Galaxies can collide without stars touching. Picture two galaxies, vast spirals of light, barreling toward each other in slow, majestic chaos. Millions of light years wide, trillions of stars, clouds of gas. Dark matter cloaks you can't even see. They don't politely swerve. They don't ask permission. They crash. And yet, nothing explodes. Because space is mostly space. Even when two galaxies collide, the stars almost never touch. They pass through each other like ghosts in a cathedral, their paths bent by gravity, their arms twisted into new shapes. What looks violent from afar is, in fact, a slow ballad. But gravity doesn't ignore it. Black holes spiral toward each other in the center. Gaseous clouds compress. That's where the fireworks begin, not from impact, but from birth. New stars ignite. Nebulae bloom. Radiation surges. Entire planetary systems are flung out into exile, cast adrift between galaxies. And we're next. The Milky Way is on a slow-motion collision course with Andromeda. A meeting scheduled for about 4 billion years from now. We call it a collision, but it won't be a crash. More like a reshuffling. A remix of stars, a redrawing of constellations. The sky above Earth, if Earth still exists, will become a swirling canvas of lights from both galaxies tangled together. It won't be the end. Just a transformation. A merging. Like two river currents blending into one. No screams. No impact. Just orbits dancing to a new tune. And somewhere, maybe, another species will look up and wonder if his beauty was always here, or if they were lucky enough to see the moment galaxies kissed. 18. You are made of star stuff. Drift back, past the galaxies, past the first stars, past the darkness before anything was named. Now come back to your body, your hand, your blood, your bones. They are older than Earth. Because every atom in you, every carbon that builds your skin, every oxygen molecule you breathe, every calcium particle in your teeth, was forged in the heart of a star. Not a metaphor, a process. In the blazing furnaces of ancient stars, hydrogen fused into helium, helium into heavier elements. The pressure unimaginable, the temperature fatal. And when those stars ran out of fuel, they died not quietly, but violently. Supernova. Explosions so fierce they rip atoms apart and glue new ones together. Iron, gold, uranium. The universe's metalwork shop, tossing elements into space like sparks from a cosmic fire. Those ashes became clouds. Those clouds became planets. Those planets became life. And eventually, you. So when you cut an apple, when you cry, when you dream, you're not just using atoms. You're recycling the ancient debris of collapsed suns. Stars that burned, bloated, exploded, so that something else could begin. Every time you blink, some of that blink comes from a supernova. And when you whisper, when you hum softly to yourself in the dark, you're not just a human speaking. You're the voice of matter remembering light. You are not simply in the universe. The universe is in you. And it always has been. 19. The symphony beneath silence. You think space is quiet. And it is, if your ears are waiting for sound waves. But the universe doesn't hum in vibrations you can hear. It sings in frequencies your body forgot how to decode. Because space is not silent. It's just tuned to a different language. Every star pulses. Every black hole crackles. Every galaxy breathes in gravitational murmurs and magnetic whispers. There are waves, radio, gamma, X-ray, moving through the cosmos like invisible music, plucking at the fabric of reality. The microwave background, a fossil echo from the birth of time itself, still rings out like a note sustained for 13.8 billion years. A baby cry stretched into eternity. Jupiter emits eerie bursts. Pulsars spin out rhythm like celestial turntables. The sun hisses and clicks in loops of plasma ballet. Astronomers build symphonies out of data. They convert light into sound. They transcribe starlight into songs you can feel with your chest more than your ears. Deep rumbles, tiny chirps, whale song from Saturn's rings, a viola made of Venusian wind. And what you realize as you float in your bed while stars drift through your thoughts is that silence is a myth. Even here, in your stillness, there's the low electric buzz of life. There's the whisper of your own atoms, charged by the same forces as quasars. You are not separate from the symphony. You are a note in it, and the song never ends. 20. The universe is not in a hurry. The stars don't rush. They don't scramble to form or fret over fading. They are patient things, taking millions of years to be born, billions to die, and still longer to scatter their ashes into something new. There is no urgency in the way the cosmos unfolds. No alarm clocks, no deadlines, just rhythm. Nebulae drift lazily across galactic arms, stretching like clouds in molasses. Superclusters pull at each other across unimaginable gulfs, slower than any dance humans could tolerate, yet unstoppable. Even light, the fastest thing we know, obeys this patience, traveling vast distances not in seconds, but in lifetimes. A photon from the sun reaches Earth in just over 8 minutes. A photon from Andromeda takes over 2 million years. And the universe itself, expanding, stretching, cooling, isn't sprinting toward a finish line. It's gliding, drifting outward like a breath held longer than time. And yet, all this slowness still adds up. Mountains wear down, planets reshape, moons escape their orbits, galaxies grow tired and dark. Entropy doesn't scream, it yawns. And as you lie here, listening for answers in the hush of midnight science, maybe you can let go of urgency too. Maybe you don't need to race. Maybe, like the stars, you are allowed to take your time. Because the universe isn't in a hurry, and you don't have to be either. 21. The shadows between the stars. Close your eyes and imagine space. Most of us picture stars, bright, sparkling, defiant against the black. But the truth is, space isn't filled with light. It's filled with shadow. The dark between the stars is not empty. It's not nothing. It's crowded with the unseen, particles, radiation, gravity wells, cold gas clouds stretching light years wide. For every star that dazzles, there are millions of things that do not shine, do not speak, do not even move. They just drift, patient, opaque. The interstellar medium, the vast fog of dust and hydrogen between stars, can blot out entire constellations. It builds over time, gathers quietly, until one day it collapses into the spark of something new. But until then, it hides, watching. Dark matter hides too. Scientists believe it makes up more than a quarter of the universe. It doesn't glow. It doesn't reflect. It doesn't collide. It passes through you as you sleep, through your walls, your bed, your bones, billions of dark matter particles slipping silently through the earth like ghosts in the attic of space. Even light itself casts shadows. Gravitational lensing, where massive objects bend light, can smear or conceal distant galaxies entirely. Their light warped, their shapes distorted, their signals delayed by billions of years. So the next time you gaze up and count the stars, remember, you're only seeing the loudest guests. The rest are still there, still waiting, in the shadows between the stars. 22. The cosmic microwave whisper. Long after the party ends, echoes remain. And the loudest echo in the entire universe is cold. Just above absolute zero, at 2,725 Kelvin, the cosmos hums with a relic from the beginning, the cosmic microwave background. It's not noise we can hear. It's not light we can see. But it's there, everywhere, wrapped around you right now, like the faintest whisper of heat from the dawn of everything. This radiation was born 13.8 billion years ago, just 380,000 years after the Big Bang. Back then, the universe was too hot for atoms to form, just a plasma soup of chaos. But when it finally cooled, atoms locked together, and light, for the first time, was free to move. That first light still exists, still travels, still passes through you every second. It's in the static of old TVs, It's in the hiss between radio stations. It's the backdrop of everything we know. A faded memory imprinted on the walls of space itself. A baby picture of the universe, stretched and cooled as space expanded around it. Astronomers map this background like archaeologists dusting off ruins. Minute fluctuations, tiny warm and cool spots, hint at the seeds of galaxies. The fingerprints of gravity, the ancient scars of existence. But even this echo is fading. Redshifted, quieted, lost to time's long breath. And yet, as you fall asleep, it remains, soft, invisible, ancient. The universe's first light, still lingering, still whispering. 23. The Great Galactic Wall. Now let's drift outward, far beyond our galaxy. Beyond our supercluster. Beyond even what we used to think of as the edge. Because the universe doesn't just contain galaxies. It contains walls. One of the largest structures ever discovered is called the Hercules Corona Borealis Great Wall. It spans over 10 billion light-years across. So vast, light from one side hasn't had time to reach the other since the universe began. This isn't a wall like bricks and mortar. It's a colossal thread of galaxies, clusters, and filaments, all woven together by gravity and time. It shouldn't exist. At least, not according to what we thought we knew. Our models of the early universe struggle to explain how something so large could have formed in just a few billion years. Structures this big aren't supposed to happen. And yet, there it is. The galaxies inside it don't know they're part of a wall. They drift, pulled by dark matter currents, locked in silent orbits of their own. And the wall itself, it doesn't stand still. It moves, stretches, shifts with the expansion of the universe. From far enough away, it's like looking at the skeleton of the cosmos. Vast, slow, humming with the memory of explosions and collisions we can't even imagine. It humbles scale. It blurs comprehension. Because when you close your eyes and look upward, you're not just looking at stars. You're looking at a web spun across forever. And that web is still spinning. 24. The sound of the universe. You might think space is silent. And you'd be right. Mostly. There's no air, no wind, no medium to carry the kind of sound we're used to hearing. No whispers between stars. No explosions with a bang. Just vast, dark quiet. But not all sound needs air. In the early universe, when everything was hotter, denser, tighter, sound could travel. The cosmos itself rang like a bell. These were pressure waves rippling through the primordial plasma, compressing and expanding regions of matter. These ancient ripples left fingerprints behind, etched into the cosmic microwave background, the afterglow of the Big Bang. Scientists call them baryon acoustic oscillations, but they are, in a sense, the universe's first sounds. Not sound in our ears, but sound in structure. Low, deep, slow, like the hum of something dreaming itself into being. And even now, the universe hums. Black holes vibrate space-time when they collide, releasing gravitational waves, ripples in reality itself. We've only just begun to detect them, using instruments like LIGO, which can feel a shift in space smaller than a proton's width. To us, it's silence. But to the universe, it's music. Not music with melody, but rhythm. Not tones, but tremors. The kind of symphony that doesn't travel through air, but through the very fabric of space-time. So when you lie still, when you close your eyes, and you imagine everything expanding, everything cooling, drifting, falling into shape, know this. The universe is still singing. You just weren't meant to hear it the way you think. 25. The empty space that isn't empty. You picture a vacuum. A perfect emptiness. A void between the stars. A place so absent of matter, you might believe it's nothing at all. But nothing is a lie. Because even in the deepest parts of intergalactic space, where not a single atom may pass for light years, there's still something. The vacuum of space isn't truly empty. It boils with potential. At the quantum level, empty space is restless. It fizzes with virtual particles, constantly appearing and vanishing in pairs, like cosmic ghosts playing hide and seek. These pairs flash into existence, borrow energy from the void, then disappear before the universe notices. Physicists call this the quantum vacuum, and it's more alive than silence. It's responsible for real forces, like the Casimir effect, where two uncharged plates in a vacuum are mysteriously drawn together, pulled by the invisible handshake of quantum fluctuations. Even gravity listens to the vacuum. Some believe that dark energy, the mysterious force pushing the universe apart, might be rooted in this jittery, vacuum-borne energy, an unseen pressure from the not-quite-nothing. And this is where the cosmist toys with paradox. Because space is full of emptiness that isn't truly empty. Because the closer you look at nothing, the more it begins to resemble something. So when you gaze into the darkness between stars and feel small, you're not alone. That darkness is moving, seething, whispering. An ocean of almost somethings waiting to become real. And as you breathe quietly in your own sliver of space, the vacuum breathes too. Endlessly. 26. Galaxies that move without a cause. You look up at the stars and assume they are stable, distant, fixed in their constellations. But beyond what the eye can see, entire galaxies are drifting. Not toward something, not away from something, but sideways, as if caught in a current with no known source. This strange movement is called peculiar velocity. While most galaxies ride the expanding fabric of the universe, some are veering off course, moving at unexpected angles, at speeds that can't be explained by visible gravitational forces alone. They aren't pulled by nearby clusters. They aren't falling toward anything we can observe. And yet, they move. Scientists call it dark flow. An eerie river of motion, stretching across vast swaths of the cosmos. Entire galactic superclusters seem to be heading somewhere beyond our observable horizon, beyond the edge of what we can see. It's as if something massive, unimaginable, exists out there, pulling. But we can't see it. Some theorize it might be a relic of the multiverse, a bruise on the fabric of our cosmos caused by another universe brushing against ours long ago. Others wonder if it hints at a structure beyond the universe itself, something ancient and unmeasured, forever hidden behind the curtain of light. Whatever it is, we feel its tug. Galaxies twist like leaves in an invisible wind, obeying a call we don't understand. So when you watch the stars and believe them to be still, remember, even they are wanderers, answering a summons written into the dark. And we, tiny observers on our quiet planet, are drifting with them, pulled toward the unknown. 27. The coldest place in the universe. You would think space is cold everywhere, but not all cold is equal. And in the quiet corners of the universe, some places are colder than the emptiest vacuum your mind can imagine. But what's strange is that the coldest place we found isn't in deep intergalactic space. It's in a nebula, a glowing, star-forming cloud of dust and gas known as the Boomerang Nebula, about 5,000 light-years away. In its heart, something is happening that defies expectation. Matter is expanding so rapidly from its central star that it cools itself down through adiabatic expansion, much like a gas cooling when it escapes a can of compressed air. The temperature here, 1 degree Kelvin, or about minus 272 degrees Celsius. That's colder than the cosmic microwave background, the natural chill left behind by the Big Bang. Colder than the fabric of space itself. It is, as far as we know, the coldest natural place in the entire universe. But even colder places exist on Earth, briefly. In laboratory conditions, using lasers and magnetic traps, scientists have chilled atoms down to a few billionths of a degree above absolute zero. So cold that atoms nearly stop moving. We are, in some corners of science, crafting artificial cold colder than the stars themselves can muster. But in the Boomerang Nebula, this is nature's doing. No wires, no lasers, just stellar death, unfolding in a frozen breath that stretches a light year wide. It's hard to imagine coldness so profound it ceases to be a feeling and becomes something more like silence. Like stillness, so deep it freezes the memory of motion. And yet, out there, it lingers. Still expanding, still cooling, still waiting. 28. Neutrinos. The ghosts that pass through you. Right now, this very second, trillions of particles are moving through your body. Silently, invisibly, without leaving a trace. They're called neutrinos, and they are among the strangest, most elusive particles in the universe. They have mass, but almost none. They travel at nearly the speed of light, but never stop to interact. They're produced in abundance by the sun, by supernovae, even by the radioactive decay inside the Earth. And yet, they're almost impossible to catch. Neutrinos don't respond to the electromagnetic force. They're blind to light, to charge, to the things that bind atoms together. To them, matter is like mist, barely there. So they pass through everything. Oceans, mountains, planets. You. Billions every second. Detecting one is like trying to catch a single snowflake in a tornado using a net made of spider silk. And yet, we try. Deep underground, in places like Super Kamiokande in Japan or Ice Cube in Antarctica, scientists build massive detectors the size of skyscrapers. Filled with ultra-pure water or buried in ice, they wait for a neutrino to strike. Just once. A flicker. A ghost leaving behind the faintest signature of its passing. What we learn from them is priceless. Because neutrinos are messengers from places no light can reach. Core collapse, supernova, the heart of nuclear reactions, the deep interior of our planet. They whisper secrets we can't hear any other way. They're like cosmic telegrams. From the birth of stars, from the death of galaxies, from before the Earth even formed. And as you lie there, breathing softly, drifting closer to sleep, know this. You are not alone. The universe passes through you. Silently. Constantly. As if you are a part of it. Because you are. 29. Dark flow. The motion no one can explain. The universe is expanding. That much we know. Galaxies are racing away from each other like raisins in rising dough. But then, something else. A motion that doesn't belong. In 2008, scientists noticed something odd. Clusters of galaxies, massive structures made of trillions of stars, weren't just drifting with cosmic expansion. They were moving, together, in the same direction, toward a specific point in the sky. This strange migration was dubbed dark flow. It wasn't caused by gravity from known structures. It wasn't predicted by cosmology. And yet, there it was, imprinted in the faint radiation left over from the Big Bang, the cosmic microwave background. Imagine throwing a handful of glitter into a calm pool, and watching it all drift toward a spot you can't see, pulled by something deep underwater. That's what dark flow is. Something is pulling everything. Something massive, but invisible. Perhaps even beyond our observable universe. Some theories suggest that it's the imprint of another universe, beyond the cosmic horizon, pulling ours like gravity through a veil. Others propose it's a remnant from before the Big Bang itself. A scar. A ripple. A memory. But no one knows for sure. What we do know is this. The galaxies aren't behaving like they should. They are in motion. Purposeful. Coordinated. As if responding to a call from outside the known cosmos. And here you are, lying still, while entire galactic cities drift toward a mystery we can't name. Not chaos. Not coincidence. Just something, waiting. Beyond the edge of what we can see. 30. The cold spot. A bruise on the universe. In the oldest light of the universe, there's a shadow. A silent, chilling fingerprint. The cosmic microwave background, that faint glow left over from the Big Bang, is supposed to be uniform. A smooth whisper of heat from a time when the universe was just 380,000 years old. But in the middle of it, nestled between the galaxies and silence, lies something colder than expected. Much colder. They call it the cold spot. It's not just a temperature dip. It's a puzzle. A drop so significant, scientists began to wonder, is it real? Or an illusion? Some say it might be a massive supervoid, a vast, nearly empty region of space stretching billions of light years across. Fewer galaxies, less matter, less heat. But even a void that big shouldn't make it this cold. Others whisper more radical ideas. That the cold spot is a scar left by a collision with another universe. A bubble brushing against ours in the early cosmic foam. A remnant of a multiverse interaction we weren't supposed to detect. It sits there like a bruise on the sky, quiet, ominous, not screaming, but unsettling. Like a forgotten hallway in a place you thought you understood. Telescopes stare, simulations run. Explanations falter. And the cold spot just remains, silent, waiting. It doesn't glow. It doesn't move. It doesn't explain itself. It just reminds us. The universe is not as uniform or as knowable as we thought. There is a wound in the cosmos, and we don't know what made it. 31. The missing antimatter mystery. Everything you've ever touched, tasted, built, or broken is made of matter. Atoms, electrons, quarks, stuff. But when the universe was born, violent and newborn, hot as thought and fast as silence, it should have made equal parts matter and antimatter. That's the rule. For every particle, an equal and opposite twin. But something went wrong. Or something intervened. Because today, the universe is made almost entirely of matter. Antimatter, the mirror opposite of regular particles, same mass, opposite charge, is virtually nowhere to be found. When matter and antimatter meet, they annihilate. Pure energy. Light and heat. Nothing left. So, where did all the antimatter go? This isn't just a quirky imbalance. It's a cosmic crime scene. A vanishing act that happened in the first microseconds of existence, and we don't know who or what was responsible. Maybe there was a slight asymmetry in the laws of physics. A tiny preference for matter, like the universe flipping a coin, and it landed on heads, 1 trillion times in a row. Or maybe, before our Big Bang, there was another universe where antimatter won. Somewhere out there, in theory, there could be galaxies made entirely of antimatter. Stars that would explode the moment they touched ours. Worlds with the same chemistry, same structure, but inverted charge. They would look like ours. They might even mirror us. But contact would mean mutual obliteration. So instead, we drift apart, unknowing, unreachable, untouchable. And in our matter-dominated universe, we carry on. As if our twin never existed. As if the universe didn't cheat its own rules to let us survive. 32. When galaxies collide, a cosmic embrace in slow motion. Out there in the cold velvet dark, galaxies aren't just islands of stars floating politely past each other. They're dancers. And sometimes they crash. But not like cars on a highway. Not like cymbals clashing in a symphony. When galaxies collide, it's more like lovers reaching out across space. Their shapes warp. Their spiral arms tangle. Gravity pulls their stars into new orbits, new trajectories, like dancers swept off their feet mid-step. And yet, most stars never touch. You could stand on a planet inside a colliding galaxy and never feel the impact. Because stars are spaced so far apart, It's like two swarms of fireflies drifting through each other. Close, chaotic, but rarely colliding. Still, the gravitational ballet is breathtaking. Gas clouds slam into each other. Shock waves ripple. New stars are born in glowing nurseries, ignited by the turbulence. And black holes at the galactic centers. They spiral closer and closer. Two monsters in slow-motion orbit, destined to merge in a burst of gravitational waves. Right now, the Milky Way is on a collision course with our nearest neighbor, Andromeda. They're set to collide in about 4 billion years. And when they do, the sky will bloom with light. Stretched arms of stars, arcs of dust, long glowing trails like cosmic brushstrokes on the canvas of space. No doomsday, just transformation. Galaxies becoming something new, like memory folding into the future. And somewhere, maybe on a tiny planet orbiting a quiet star, a being like you might look up at the sky and wonder what came before. 34. The dark flow. A tug from beyond the observable. There's something pulling on galaxy clusters. Something big, something we can't see. Astronomers call it the dark flow, a strange, directional movement of matter in the universe that doesn't match what we expect if everything were expanding evenly from the Big Bang. It's as if our entire observable universe is being gently tugged towards something outside the cosmic curtain. A gravitational nudge from a mass that's too far away to observe, too far for even light to reach us. Like a current beneath still water. We don't know what's causing it. Some theories whisper about massive structures beyond our cosmic horizon, superclusters of galaxies we'll never see. Others entertain even stranger possibilities like multiverses. Maybe our universe is just one bubble in a vast cosmic foam, and one of the other bubbles is brushing too close. It's not the same as dark matter, or dark energy. It's not even necessarily a thing. It's a direction, and that makes it eerie. Because for all our science, for all our telescopes scanning the skies, there's still something out there, pulling on our galaxy, on thousands of others, with a silent insistence. A reminder that the universe doesn't end where our instruments give up. That beyond the farthest star we can see, there may be something even larger, even stranger. And even now, as you lie still in your bed, your atoms gently humming in place, your galaxy may be drifting toward the unknown. 35. The cold spot. A cosmic bruise in the sky. If you look at the universe as a baby, just a few 100,000 years old, it left behind a photograph. A faint glow stretched across the sky. We call it the cosmic microwave background, or CMB. It's the afterglow of the Big Bang itself, the earliest light. But in this ancient picture, there's a blemish. A patch of sky noticeably colder than the rest, colder than it should be. Scientists call it the CMB cold spot, and it's not just a little hiccup in temperature. It spans over 1.8 billion light years, an enormous emptiness stretching across time and space. Some say it's just a statistical fluke, a place where the early universe cooled a little unevenly. Others think it might be a supervoid, an unimaginably large region of almost nothing, with very few galaxies at all. But then there are the weirder explanations. Some researchers have floated the idea that this cold spot might be evidence of a collision between universes. A scar left over from when our bubble universe bumped into another in the multiverse foam. Like two soap bubbles nudging in a sink, leaving behind a warped, cooler edge. Whatever it is, the cold spot remains one of the greatest mysteries in cosmology. Not because it's loud or dramatic, but because it quietly defies what we expected. A cold fingerprint on the baby picture of everything. And as we stare into that quiet patch of sky, we're left with one unsettling possibility. Maybe our universe has a past that isn't entirely its own. 36. The sound of the early universe. Close your eyes. Now imagine a sound so deep, so stretched, so low, that no human ear could ever truly hear it. That's the sound the universe made. Once. In its infancy, the cosmos wasn't silent. It was a symphony of pressure waves rippling through a hot, dense plasma of particles and light. These were not sound waves in the way we hear them on Earth, but acoustic oscillations, ripples that would one day shape the entire structure of the universe. What we now call baryon acoustic oscillations are the fossilized echoes of that sound. Waves that move through the primordial soup, compressing and rarefying matter, forming a kind of rhythm in the distribution of galaxies we still detect billions of years later. The universe rang like a bell. Physicists have even tried to reconstruct what it would sound like if you could shrink down space and crank up frequency to fit it into our auditory range. The result? A deep, ever-rising tone, like a cosmic throat singing, climbing in pitch as the universe expanded. Each note marks a moment of evolution. Each vibration echoes a transformation, from plasma to matter, from chaos to structure, from noise to silence. And then, quiet. As atoms formed and the universe cooled, those sound waves faded. The music stopped. Light broke free, and silence thread. But the rhythm remains, hidden in the way galaxies cluster, stars gather, and matter arranges itself. The universe once sang itself into form. And we are still dancing to that long-forgotten beat. Part 37. The Invisible Sculptor. Dark Matter's Silent Hand. You've never seen it. You've never touched it. And yet, without it, galaxies wouldn't exist. Dark matter, this elusive, unlit substance, makes up nearly 85% of the matter in the universe. But it doesn't shine. It doesn't burn. It doesn't collide or clump like ordinary matter. It simply pulls. Imagine trying to trace the wind by watching the sway of trees. That's how we found dark matter, not by seeing it, but by watching how galaxies spin too fast to be held together by visible mass alone. Without this invisible glue, the outer arms of spiral galaxies would fling themselves into deep space. Stars would scatter. Planets wouldn't form. The architecture of the cosmos would collapse. And yet, it's utterly silent. It doesn't interact with light. It slips through detectors, ghosts through planets, passes through your body as you sleep. And still, it shepherds galaxies, guides the formation of galaxy clusters, and maps out the great cosmic web that stretches across billions of light years. Some theories suggest dark matter may be made of exotic particles, WIMP, actions, sterile neutrinos. But no one knows. Entire detectors have been built underground, inside mountains, beneath oceans, all listening for a whisper that may never come. And still, the evidence surrounds us. It's in the way galaxies dance, the way light bends around invisible mass, gravitational lensing painting shadows of a sculptor we cannot see. It's there, everywhere, shaping the universe not with force, but with quiet insistence, a silent architect, a cosmic scaffolding, holding the visible together like threads between stars. You are surrounded by something you'll never see. And yet, it holds you, right now, in orbit. Part 38. The universe without us. What happens after everything dies? Close your eyes for a moment and imagine a time with no stars, no planets, no warmth, no light, just endless, silent blackness stretching forever in every direction. This is not science fiction. It's the distant future. Far beyond the age of humanity, trillions of years from now, our universe is still expanding, still cooling, still aging. But the galaxies are growing lonelier. Their stars, like candles, flicker and go out one by one. Red dwarfs, the longest burning stars, sputter their final embers. White dwarfs fade to cold, black corpses, black dwarfs, invisible and silent. Massive stars die sooner, their remains collapsing into neutron stars and black holes, now drifting through the dark like seas with no soil to grow in. Eventually, Even black holes will die. They will radiate away their mass, evaporating through a process called Hawking radiation. Not quickly, but over unimaginable stretches of time minus 10,100 years and beyond. A number so vast, it makes the age of our universe look like a blink. When the last black hole dissolves, the universe will reach a new chapter, heat death. No gradients of energy. No potential for work. Just particles, spread thin, moving aimlessly in a frozen void. No light. No sound. No memory. Not even time, in any meaningful sense. And yet, in that final silence, there is a kind of peace. The ultimate stillness. A soft exhale that never ends. Not with fire, not with collapse, but with a sigh. The universe, after everything, falls asleep. Part 39. The shadows between galaxies. Not every corner of the universe is lit by stars. Far beyond the spiral arms of galaxies, outside the glowing fog of nebulae and the bustling chaos of cosmic clusters, there exists a vast emptiness, dark, frigid, and silent. This is intergalactic space. A place so empty, a single atom might drift for years without meeting another. Yet, it's not truly nothing. These voids are stitched with invisible threads, cosmic filaments made of dark matter and ancient gas, faintly glowing only in the deepest radio and X-ray frequencies. Like veins beneath skin, they hint at structure in the vastest places, where no light shines. Occasionally, rogue stars wander here. Flung from galaxies by gravitational slingshots, they drift alone in these gulfs. Some are wrapped in clouds of hydrogen, tiny traveling systems with no sun, no neighbors, no name. And black holes, too, some ejected in cosmic collisions, move silently between galaxies like ghosts. No light betrays them, only the occasional bending of starlight or the rare eruption of captured gas. Even time behaves strangely out here. With no gravity wells to pull at it, and no clocks to measure it, time in the void becomes abstract. Just a gentle glide, undisturbed. Scientists call these regions the cosmic deserts, but even deserts have winds and heat. This is colder, lonelier, more absolute. The shadows between galaxies are not empty. They are the untouched pages between chapters, the silence between thoughts, the breath the universe takes between pulses of creation. And somewhere in that silence, a photon travels still, sent billions of years ago, unreceived, unbroken, eternal. Part 40. The universe will forget us. One day, everything you know will be gone. Not because of war, not because of fire, but because time is patient, and the universe forgets. Stars will burn out, not in bursts of drama, but with slow exhaustion. Red dwarfs, the most stable, will outlast them all, glowing dimly for trillions of years before flickering into blackened embers. Galaxies will drift apart, too distant to see each other. The sky will go dark. Planets will unmoor. Moons will vanish. Even the leftovers, the dead stars, the collapsed cores, will spiral into black holes. And those black holes, they will die too. They'll evaporate over unfathomable stretches of time, releasing a whisper of radiation into the cold. Hawking radiation, the last breath of monsters. Eventually, there will be no light, no atoms, no reactions, just the thin, fading echo of a universe that once danced with stars, symphonies, and sleep. Even memory won't survive. There will be no one to remember Earth, no trace of Beethoven, no shadows of trees, no sighs of whales. Just silence, perfect and wide. And yet, in this moment, here and now, you exist. Against impossible odds, you are made of stardust. You are warmth in a cold universe. You are thought, curiosity, wonder. You are the part the cosmos made conscious, even if only briefly. And though the universe may one day forget you, tonight you've remembered it. so close your eyes. Let the galaxies drift, and float with them quietly, forever.